Today we're going to be talking about how to subtract fractions with unlike denominators. We're going to start with a problem that you may already know how to solve. What I'd like you to do is pause the video and try to solve this using your math composition book. Pause it now and then come back and see how well you've done. Using the steps that we've discussed in the past lessons, the first step would be to rewrite this problem standing on end. The second step would be to check your denominators to see if they're the same. We have a 3 and a 4. And these aren't the same denominators. Therefore, we can't add or subtract them. So we must find first a common denominator so we can convert these fractions into new fractions that can be subtracted. Our common denominator, there's a couple of ways to do that. The first tip that I've taught you would be to look at the largest denominator, in this case the 4, and ask yourself if 4 would work as a common denominator. The problem with that is if we try to put 4 here, there's no way to put 3 into 4. There's no multiplier for that, so that's not going to work. So the next thing I would advise you to do would be to look at both denominators, and if it's easy enough, go ahead and multiply them. That will get you 12. This will work every single time. 4 times 3 is 12. We also realize that one of the benefits of that is that we already know our multipliers. So here on the bottom fraction, 3 times 4 equals 12. 1 times 4 then equals 4. We have our new fraction. On the top, we have 4 times 3 equals 12, and 3 times 3 equals 9. There's our new fraction on the top. We now have common denominators, and now we can subtract. 9 minus 4, subtracting our numerators. 9 minus 4 is 5. Denominator will stay the same. And there we have our answer, which we know may not be the final answer. We know that we need to look at that final answer and see if it can be simplified. Is there a number, a divisor we can use that will go into both 5 and 12? If you recognize 5 as a prime number, talked about that a little bit in the past. Prime numbers are special kinds of numbers. They only have 2 numbers you can multiply to get them. That would be 1 and themselves, and the only 2 numbers you can multiply to get 5 is 1 and 5. So 5 is a prime number, meaning there's only 2 numbers you can divide that by. That would be 5 and 1. We never divide by 1 when we're simplifying fractions. That would be a waste of time. We would end up with the same fraction. We can't divide 12 by 5. That's not going to work. It has to go in evenly. Therefore, we are finished. This will be your final answer, 5/12. I'm going to give you a couple of problems to solve, and you'll be able to pause and come back and check your work, see how well you've done. Okay, take a second, write this problem down, pause the video now, solve it, and come back and see how well you did. All right, first step. I know that you rewrote this problem standing up. Second step, I know you checked your denominators to see if they were the same. We're working with unlike denominators today, so they're not going to be the same. Step 3, actually step 2 still, if they aren't the same, we need to make them the same. So tip number 1, take a look at your biggest denominator, 7. Ask yourself if 5 will go into 7. We'll need it to go into 7 evenly. It won't. Therefore, the easiest way to find a common denominator, again, is to take the 2 you already have and multiply them, and you'll get 35. 35 will become your common denominator. Now we need to change our numerators. Our top denominator, we have a multiple. We know what it is because we multiply 5 times 7 to get 35, so we'll do the same to the top. 7 times 4 is 28. The bottom one, we need to find our multiplier as well. Again, that will be easy because we multiplied 7 times 5 to get 35. And we'll do the same to the top. That will get us 10. Now we're subtracting. Pay attention to the sign. Make sure we know what we're doing. We're going to be subtracting our numerators. 28 minus 10, which will get us 18. And the denominator is 35. No whole numbers to subtract because these are not mixed numbers yet. This was your initial answer. We'll be checking this answer to see if it can be simplified. Is there a number that goes both into 18 and 35? Let's take a look at the numbers that go into 18. 18 times 1, of course, is 18. Any other partners you can think of? 9 and 2. Any other partners? 3 and 6. There are quite a few numbers that go into 18. Let's take a look at 35 and see which numbers go into 35. 35 and 1, of course, and 7 and 5. Those are the only other two numbers that go into 35. So what do we have in common here? The only common number we have that goes into both of them is 1. Therefore, this number cannot be simplified, and this is your final answer. This time you're going to be practicing a mixed number. I'd like you to pause the video now, try to work out the problem, and come back and see how well you did. Okay, welcome back. Step 1, of course you rewrote the problem, standing on end. And step 2 was to take a look at your denominators. Are they the same? We have a 10 and a 2, so they're not the same. Then we need to make them the same, and again, going back to my first tip on how to find a common denominator is always look at the largest denominator. Our largest denominator is 10. So we are going to ask ourselves, can we use 10? 10 will, of course, work here. Will it work on this fraction? Will 2 go into 10 evenly? Yes, it will. So we're going to use 10 as our common denominator. That would make the bottom fraction exactly the same as we multiply by 1 to get that. And we're going to use 10 here, which would make our top fraction 5 because 2 times 5 is 10, and therefore we do the same to the top. Now we can subtract. Put my sign in there. 5 minus 1, our numerators get you 4. And our denominator will not change. That will still be 10. And now we have two whole numbers to subtract. 3 minus 1, which is 2. Now are we finished? No, we're not. We need to look at our final fraction and ask ourselves if it can be simplified. Is there a number, what we would call a divisor here? Is there a divisor that will work for both of these numbers? One for sure way of knowing is to write out the multiples of each number. So if we write all the multiples of 4, the numbers that go into 4, they would be 4 times 1, which is his partner, and 2 times 2. And since it's 2 times 2, we only need to write that once. And for 10, we have 1 and 10, and we have 2 and 5. And we can now see that we have a common factor, a number that goes into both of those numbers, and so we should be using that to divide. 4 divided by 2 is 2, 10 divided by 2 is 5. This is our simplified fraction. We could ask if we could do this again, but 2 is a prime number. It only has 2 numbers that go into it, the numbers 1 and 2. And since we can't divide 5 by 2, we're as simple as it can get. So our final answer then is going to be 2 and 2/5. We have to combine our whole number with our fraction, and this is no longer needed. Congratulations if you got that right. And I'll see you next time for lesson 1-9.